Welcome to homework.
We're asked to give recursive definitions of sets. In part A, we're given S is the set of even integers. So we first have 0 is an even integer, so it's an S. We have that every even integer is the previous even integer increased by 2. And so we have that S plus 2 is contained in S whenever S is contained in S. And we also have that every even integer is the next even integer decreased by 2. So we also have that every even integer is next even integer decreased by 2. And so it also follows that S minus 2 is contained in S whenever S is contained in S. And so it follows that our recursive definition is going to be that 0 is an S, S plus 2 is an S, if S is an S, and S minus 2 is an S, if S is an S. Now in part B, we're given that S is the set of positive integers congruent to 2 modulo 3. First positive integer congruent to 2 modulo 3 is, of course, 2. And we have that every positive integer congruent to 2 modulo 3 is the previous positive integer congruent to 2 modulo 3 increased by 3. So every positive integer congruent to 2 modulo 3 is the previous positive integer congruent to 2 modulo 3 increased by 3. And if we translate this into set notation, this means that S plus 3 lies in S whenever S is an S. And so we can take as our recursive definition that 2 is an S and S plus 3 is an S whenever S is an S. Now in part C, we are given that S is the set of positive integers not divisible by 5. So nescence means that S contains all positive integers congruent to 1, 2, 3, or 4 modulo 5. So first, we have that the first positive integer congruent to 1 modulo 5 is 1, so 1 is going to be an S. We have the first positive integer congruent to 2 modulo 5 is 2, so 2 is an S. And the first positive integer congruent to 3 modulo 5 is 3, so 3 is an S. And the first positive integer congruent to 4 modulo 5 is 4, so 4 is an S. And we also have that every positive integer congruent to 1 modulo 5 is the previous positive integer congruent to 1 modulo 5 increased by 5. And this is also true for 2, 3, and 4 modulo 5. And so we also have that S plus 5 is contained in S whenever S is an S. So this is the other part of the definition.